Howdy, I'm Elise. I'm in Chem 120, and today we're going to go over solving ice tables and the reaction quotient. And so the purpose of this is just to find the equilibrium concentrations of different reactions. And there is about a 7-step process in doing so. And so that first step is simply going to be writing and balancing the chemical equation. The second step is going to be writing the equilibrium expression using K, the equilibrium constant. And all it is products over reactants, making sure to put that product or reactant to the power of whatever the coefficient is in the balanced equation. The third step is just going to be listing the initial concentrations, which are given to you in the problem. And if it's not listed, then that initial concentration is just going to be 0. You then have to determine what the shift in equilibrium is. And so in the problem example given, if there is a 0, then that shift is just going to be towards that 0. So here it's shifting to the right, going from negative positive because you have too much reactants, you need to transfer some to the products to create that equilibrium. If all products and all reactants are present at the initial of the reaction, then you use the reaction quotient, which is going to be the same expression as the equilibrium expression. However, the concentrations will not be at equilibrium. And then from there, all you have to do is compare the Ks to the Qs to determine whatever that shift is. The fifth step is going to be defining the change needed to reach equilibrium, and you just do that in values of Ks. You bring down that coefficient, then you have the X variable, and then whatever side that it's shifting to or from, you have the negative or the positive signs. And then the sixth step is just defining the equilibrium concentrations, and you just combine the I and the C to get whatever that equation or expression is needed to find the concentration equilibrium. The seventh step is simply just plugging in these numbers into that equilibrium expression and just solving it from there. And then you just move everything over to isolate a variable. If K is about less than 10 to the power of -5, then you can ignore, which is already highlighted here, any minus or positive x's because the change is going to be so small. If you can't do that, then just do the same thing, isolate or bring all the variables to one side, and then use the quadratic formula to find the x. And then from there, using that x, you are able to find whatever the equilibrium concentrations are for both the reaction and the products using those the expressions of equilibrium concentration.